What is a pole? A pole is something that looks like this one. So, and actually, it's something very meaningful. Think at Laplace. You will see from the visualization from Laplace, a pole is actually something that goes up in the modulus. It's actually a pole. It's actually a pole. So, there's differences between single and multiple poles, and we need to discuss also what poles are from a physical perspective. So we have this representation. That means that we have this partial fraction decomposition. True? Are we together? How much are we together on this? We do partial fraction decomposition. We get this stuff here, and we have all the various partial fractions, potentially with some powers here. And then it means that h is a sum of h. That means that small h is a sum of small h. True? This is what we were using. It's linearity. It's essentially linearity. Excellent. H of t is the weighted sum of all the impulse responses relative to the various poles in the partial fraction decomposition. This by itself would be an impulse response. This by itself would be an impulse response. Actually, these and these that are transformations. We are going to call those ones modes. We take an H, partial fraction decomposition into simplest fracts. Each anti-transform is a mode. That means how many modes will I see for this H of S? 3. Or better, 2 if we put them together. This is one source of confusion, so now we have to discuss it before kind of going on. If I have this stuff here, degree of this equal to 3. True. We would write this d as s plus 7, s plus 2 plus j, s plus 2 minus j. True? We will write it in this way. To be honest, if you do partial fraction decomposition with complex poles, we would get something here plus something here plus something here. We would get 3 stuff. And then we will get this one. I hope you see it. This one would be, let's put numbers, 9, 10, 11. This one would anti-transform into 9e minus 7t for t bigger than 0 and 0 otherwise. Are we together on this? We are together on this, true? This one would anti-transform in what? 10e minus 2 minus j. True? No, plus j. No, minus j. The minus j, t. For t bigger than 0, 0 otherwise. True? True? This one, in time, this object here, how would it look like in time? T, real part, imaginary part. True? True? And this one, it has to be actually 10 here too. It cannot be. This one would look like this one. True? That means like this. If you sum up those two, what do you get? E minus 2t cosine t. Euler formula. See? But This is the main message. We have 3 poles. That would mean 3 complex modes. But whenever we have complex conjugate stuff, the complex conjugate stuff blends into pairs of complex modes into one single real mode that is of the type E cosine or E sine. You got the point. Together? So this is kind of the confusion that sometimes people tend to make, and it's a little bit, how do you say, weird. You might say we have 3 modes, or you might say we have 2 modes. Okay? Together? Because depending on the standard, how you mention what is a mode. If you consider in your mind a complex mode or pairs of complex modes as a single mode. Are we together? Let's make an exercise. Would you say that you have 3 modes here? No, either you say that you got 4 modes or you say that you got 2 modes. True? Together? Perfect. Okay, so what is a mode? Is a single of those 8. Are you considering complex modes or real modes? Depends on your notation. We got intuitions. It's kind of a single component that creates this object here. Okay? Let's make an exercise. I see h of t made in this way. This is my h of t. Where are the crosses? Sigma, omega. This is h of t and t, of course. Go, discuss. Go if enough. Somebody that says the first thing that they notice, which fundamental mode would you say here? Which fundamental mode do you see here already from how this ends? Step, true? We have a step. This is the first one, true? So where is it? Where is the cross corresponding to a step? Here, true? Together, together, perfect. And then what do we see also? We kind of see it immediately. It's my exponential here that goes down. True? Together, how many modes? 2 or 3. Let's make 2. I like more saying 2, to be honest. But depends on how we are. Vivo stable? Yes, no, I do not know. Very much no. Is it absolutely integrable? No. Example of a physical system that might have this impulse response. Think of a system that might have an impulse response like this. I give you an intuition. There's an oscillation. So you hammer it, it moves and oscillates. What can it be? Go. Yeah. Come on, come. Let's see if I can reproduce it. No. Look at it, people. Look at it. Excellent. I didn't think about it. I thought I kind of a pole, then oscillating, but this is the same. And then does like this. True. It's a bottle that you push and it moves, and then it does like some oscillation. Ta 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 ta. It's non-linear. Actually, it's not. It's not perfectly because it's not a perfectly linear behavior. There's a little bit of switching thingy, but you kind of get the point. So it's kind of something that you push, it will move, and then it has got some oscillation due to some elasticity effect. Together, people. For me, it's easier to think in terms of mechanical systems. There's people that find it easier to think in terms of electrical systems. You choose the one that you want, okay? Okay. Interesting thing. We saw, whenever we did partial fraction decomposition, we saw this cover-up method, true? The one of covering up one pole. In a certain sense, whenever we go from this one to this one, and these ones, they are simple, so all the powers are 1, those objects here can be found, that basically give you the intensity, can be found by this cover-up method. This is the cover-up method, essentially. Let's make an exercise. H of t, find it. For this one, find it. This one is going to be a s plus 1 plus b s plus 2. Go, find it. People, the stuff here at the exam have to be like this, okay? At the exam, the stuff here, no doubt. A, how do I find A? Go. Try, people, try. I see several people that is not trying. You don't have to think too much. No. You write it down. No, you write down two equations, but you've got to. You cannot stay 5 minutes thinking which algorithm do I need to apply for finding A. I also do not see A immediately. I've got to write it like this. Okay, so A, S plus 1, I've got to put this one to 0. It means that I need to put minus 1. This is 3. Okay, now let's go here, this one. This one, I've got to cover this one. S has to be minus 2, so minus 2 plus 1 minus 1, minus 3. This speed is acceptable. So, are we together? That means that this one is going to be 3e minus t plus minus 3e minus 2t for t bigger than 0, 0 otherwise. Okay? How does it look like? Watch out. How does it look like? Plot it by yourself. That's it. Plot it by hand. I'm bad in drawing, but let's see. I would have found a solution. I found a solution. With few minutes more, I would have found a solution. I was lost. Let's just to see where we are. So E minus t, I draw it. What did I draw with the stuff here? With the stuff here, what did I draw? What did I draw? What did I draw with the stuff there? I drew the time constant. You remember the time constant? If you don't remember the time constant, we check the time constant. To find the time constant, I take like the stuff. This one and this one is going to have half the time constant. True? So I went here, I took half, and I did like this because they start both at 1 and minus 1. True. This one starts at 1. This one, actually, it's a minus beforehand. This one starts at minus 1. True? And it has to start in this way. Then I take this and this, I sum up that together. This one goes to 0 faster than this one. It has to do something like this. Together? Okay. This one is also interesting. Do you remember this connection, people? Do you remember this connection? Free, like if it is a pole with a square, then it gives a t. Cube, it gives t square. Fourth power gives t to the power of 3. Okay, there's a minus 1 here. Okay, this stuff here, let's do not forget it. Okay. Let's plot it. Plot t, e minus t by hand. Go. How do you do? I think we didn't see it before. True. Did we see how to plot it by hand before? Maybe not. Okay, then I say it. T, the mode of t. For t that is close to 0. This stuff here will be what? 0. True? Close to 0. If I have this times this one for t equal to 0 is 1. For t equal to 0, this stuff is 0. 0 times 1 equals to 0. If I've got t equals to 10 to the power of minus 10, this stuff here is going to be, 1. This stuff here, 0. At the beginning, this stuff here starts like t, because at the beginning of time, for t that are small, let's say that 1 is this one. For t that is small, this term dominates this term. Are you seeing me? Perfect. So we start like this. For t equals to 10 to the power of 10, this one is going to be 10 to the power of 10. This one, e to the minus 10 to the power of 10. Who is going to be? Is going to be, this is big, this is small. The product of the two, is it going to be big or small? Small, very small. E dominates. For t big, E dominates. This does like this. And if I've got t square, how do I do? At the beginning, t square wins, and then E wins. Okay? See? Together? Question.
Is this somehow connected to what you were seeing at the beginning? Like, imagine of increasing the exponential of t. We get like the more like steep thing or not?
No, because the crest moves also. The crest moves. There's in the Python notebooks there should be, or in the GitHub of the course there should be the explanation how the stuff moves. If not, by tomorrow I prepare it. This stuff here doesn't have a Laplace, that is the Laplace that we like with a rational transfer function. So this is kind of a case that I remember. This case here is not leading to a rational transfer function or rational representation in Laplace. So it's not of our interest. This one is a signal, but in a certain sense, it's not a signal that is interesting for making use that we can use with making use that we can use with Laplace. Okay. Watch out, people, that sometimes you might, by looking at only this stuff here, by looking at only this one, if we were getting an impulse response, if we were getting a response looking like this one in time, might not be immediate to see what are the constituents. Okay, so watch out that not everything you can see by looking at it. Okay, together takes domain expertise to kind of realize which components the signals have. But we are there. Let's go to something like this. If I have an H of S looking like this, which components would the H of T have? Go, this time. Tell me the components. Don't tell me the effect of the zeros. We are going to see the effect of the zeros later. And then something plus something plus something plus something. True? We do not know the numerator. We would have to expand and to do the partial fraction decomposition. Where we have in time, we would do it. Kind of not very relevant. By looking at this stuff here, I know that H of T will have 1, 2, 3, 4 modes. Okay? How much are we together, people? Other questions? Let's make another example. If I have, which type of modes will I see? Sigma, omega. Let's say 7 minus 7, 10. I'm going to see something e minus 7t cosine 10t plus something t e minus 7t cosine 10t. Very much together, not at all. Why are there dots? It's a double pole, true? So it's kind of it's immediate. Okay. Other questions, people?
For these last ones, really, just because you're considering decompose them, because if you consider them all together, we just have t e minus 7t, right? We keep the denominator and just one.
No. If we divide in 4, so here I'm dividing in 2 modes.
I do not like
Then I would have something that is my H of S. My H of S would look like something numerator, and then I would have S plus 7 square plus 10 square square. True? I think I'm forgetting a parenthesis. Okay. Come on, shall we together, people? 1, 2, 3. And then let's do this one. Go. So people, what would you say? This one should be. So 3 is wrong. Why 3 is wrong? It's not for any rational function. S plus 2 square. This is rational, but you cannot do it. I think that now I see it. This one is actually a little bit wrong whenever it's not specified that it's rational, because it might be irrational with all poles that are simple, and then you cannot do the cover-up method. I think it's in a certain sense because it's a badly written question. Now that I think a little bit better about this, it's kind of misleading. Do you see why I think I'm kind of not I didn't write it in a good way? I see it. I don't see it. Why you? No. S plus 1, S plus 2, S plus 3. If I go on forever, this one, is it a rational transfer function? No, it's irrational. That's an infinite poles. Do you see it, people? 1, 2, 3. Do you see that if I've got perfect? Would you be able to do partial fraction decomposition there? No, because you get infinite poles. True. Question. With as soon as you have single poles, you can, but you need to have a finite denominator. So only when all poles are simple, but denominator of S has a finite order. Okay, so this was the correct answer. How much are we together, people? 1, 2, 3. Okay. No. If I have this one and square, I can't use the cover-up method. Okay, I need to do the system. Okay. Perfect. Other questions, people?